You know, some stories sound like they're ripped straight from the history books of Silicon Valley. But this is happening right now. We're talking about a massive technological breakthrough, and you will not believe where it came from.
And no, I'm not kidding. That's not some kind of metaphor for a small startup. This chip, this incredibly complex, working piece of silicon, was literally made in a garage. Yeah, the place with the lawnmower and the Christmas decorations.
And get this, it's not just some simple little circuit. We're talking about a chip with 1,200 transistors packed inside. That's a huge number. It's a level of complexity that just completely changes the game for what we thought was possible for do-it-yourself electronics.
So to really get why this is such a big deal, you gotta look at where this all started. The very first chip made in this garage, called the Z1, had just 6 transistors. 6. This new one, the Z2, multiplies that by 200. That's not just a step up, it's a giant exponential leap. Okay, so this chart right here really puts it all into perspective. See that tiny little bar? That's the first chip with 6 transistors. And then, bam, look at that jump to 1200. But here's the kicker. See that other bar? That's the legendary Intel 4004, the first ever microprocessor. It had 2200 transistors, and it literally changed the world. This garage-built chip is playing in the same ballpark. It's incredible.
So, is this just about cramming more transistors onto a chip for bragging rights? Absolutely not. The really important thing here is that the technology itself took a huge leap forward. And that's what makes this chip not just a cool novelty, but something genuinely powerful and, actually useful.
So what was the secret sauce here? Well, it all comes down to a change in the manufacturing process. The old way used what's called a metal gate. It worked, kind of, but it needed a ton of voltage to run. We're talking over 10 volts. That's a no-go for modern electronics. The new method? It uses a polysilicon gate. And that might sound technical, but it's the exact same core technology that kicked off the entire semiconductor revolution. This is the real deal. And the results? Just look at this table. You don't have to be an engineer to see how amazing these numbers are. Check out the threshold voltage. That's how much power you need to flip the switch. It's down to just 1.1 volts. And the leakage current, which is basically just wasted energy, it's super, super low. These aren't the numbers you'd expect from a science fair project. This is a high-quality, seriously efficient transistor.
So what does all that low-voltage stuff actually mean for us? Well, it means this homemade chip can finally speak the same language as modern electronics. It can actually connect to and work with the standard 2.5 and 3.3 volt circuits that run, well, pretty much everything these days. This chip has officially graduated from cool experiment to practical tool.
All right, so the big question is, how on earth do you do this? How do you build a microchip without one of those billion-dollar cleaner-than-a-hospital labs? The answer, my friends, is pure, brilliant ingenuity. We're talking about hacking the process itself.
And this quote from the creator just nails the whole philosophy behind it. The goal isn't to build a mini version of a professional factory, or fab. It's all about finding clever shortcuts to get to the same result, without the crazy expense, the mind-boggling complexity, and, the super dangerous chemicals.
And some of these workarounds are just genius. For example, instead of dealing with silane gas, which is both toxic and explosive, by the way, to create a layer of silicon, he just bought silicon wafers that already had that layer on them. That one simple move also meant he didn't have to mess with nasty stuff like sulfuric acid for cleaning, because the most important part came prepackaged and perfect right from the factory.
So suddenly the whole process, while still really hard, becomes something a person can actually manage. It boils down to these steps here. You start with that pre-made wafer, you etch out the spots for your transistors, you dope them, which is just a fancy word for tweaking them so electricity flows the way you want, then you create the gates that act like tiny switches, add the metal layers for wiring, and finally carve out the connections to hook everything up.
Okay, so making a 1200 transistor chip in a garage is obviously super cool. But let's step back for a second. Why does this really matter? This is where this story goes from being a really impressive hobby project to something with potentially massive implications. What we're seeing here is the beginning of the democratization of some seriously advanced tech. I mean, think about it. For decades, making computer chips has been the textbook example of an exclusive club. You need factories the size of small cities, costing billions of dollars. You need clean rooms where the air has fewer particles than an operating theater. It is the absolute polar opposite of a weekend hobby in your garage.
But this whole experiment proves a point that is frankly revolutionary. It shows that you can, in fact, make really good high-performance transistors without all that insane infrastructure.
It was done with no clean room, with chemicals that would make a professional fab engineer faint, on equipment built by hand. Sure, you're not going to get the same results as a multi-billion-dollar plant every single time, but that's not the point. The point is, the barriers to entry that we all thought were sky-high, they just got a lot lower. A door has been kicked open.
So, what now? What does the world look like when making your own custom silicon isn't just something that giant corporations can do? What's next?
You know, this quote really gets to the human element of it all. It's not just a technical win. This is a story about pure passion, about curiosity, and about that incredible feeling of taking, literally, a piece of rock, dipping it in some chemicals, and making it think. That excitement, that's the fuel for every great invention.
And that leaves us with a really powerful thought. The personal computer revolution started in a garage. The social internet revolution started in a dorm room. And now, the very power to create the fundamental building blocks of technology is back in the garage. So if someone can make a 1200 transistor chip at home today, what world-changing thing is going to be invented there tomorrow?